Hans Christian Oersted, a Danish physicist, was the first scientist to successfully connect electricity and magnetism together in 1819. Oersted came up with a hypothesis that a current produces a magnetic field that radiates away from the wire.
Oersted placed a compass so that it was aligned with the wire. To make things simpler, imagine a wire that is placed onto a table that is pointing north. Since there was no current generated yet, the compass points parallel to the Earth's magnetic North Pole.
He switched on the circuit after his first observations. Instead of remaining parallel to the wire, the compass instead deflected and became perpendicular to the wire, therefore showing signs of the current's magnetic field. Afterwards, when the current was switched off, the compass needle resumed its previous state and points to the North Pole, parallel to the wire. Magnetic fields will always surround the conductor, the wire that the current is flowing through in the experiment, in the shape of circles. The farther the distance the magnetic fields are from the wire, the weaker the strength is. The direction of the magnetic field is dependent on the direction of the current. Oersted's principle states that a circular magnetic field is produced around a straight conductor when a charge or current is moving through it. There are two techniques to help determine the direction of the magnetic field. Right-hand rule for a straight conductor. Using your right hand, imagine holding the straight conductor in your palm like you would hold a microphone. However, your right thumb should be sticking parallel to the conductor and should be pointing towards the direction of the conventional current. Your curled fingers are pointing in the direction of the magnetic field lines. Keep in mind that electron flow and conventional current are two different things. The conventional current flows from the positive to negative terminal, and the electron flow is flowing towards the negative to positive terminal. If wanting to determine the direction of the magnetic field lines according to an electron flow model, repeat the same procedure as you would with the right-hand rule, but switch from using your right hand to your left. This is commonly known as the left-hand rule for electron flow in a straight wire. To represent currents and magnetic fields in a simple diagram, we use the simple X and dot in order to show whether a current is going into or out of the page. Imagine yourself shooting an arrow at a target. After letting go of the arrow, you will see the tail forming an X, which in turn shows that a current is going into the page. Now imagine someone shooting an arrow at you. Instead of seeing an X, you will see a dot, which corresponds with the tip of the arrow. This represents the current coming out of the page. When you have figured out the current's direction, put the symbol X or dot onto the beginning of your diagram and draw a small circle around it. This will be your conductor. Use the right-hand rule in order to find out the direction of your magnetic fields, and then draw a few more circles around your conductor to represent the magnetic fields. Be sure to include little arrows onto the circles in order to indicate the direction of the magnetic field.